Hi, this is Prashant Jinde. It is another session in the series of online lectures of the subject Basics of Fiber Science. So let's start with the topic number 2, which is named as Methods of Fiber Manufacturing. I'm going to give you a glimpse what we are going to learn in this topic number 2. In this topic, we will be covering different methods of fiber spinning, that is melt spinning, dry spinning and wet spinning. In addition to that, we will be covering the advantage and disadvantage of each method, the definition of a POY, MOY, LOY and FOY. But before starting the different points in the topic, let's aware the different terminologies that we are going to use or it will be useful in further learning. So the first terminology is fiber spinning. Earlier, I told you that fiber spinning is nothing but the process of producing fibers from the polymer. Conventionally, we are aware that fiber spinning is nothing but production of yarn from the fiber. But in this subject, Basics of Fiber Science, the fiber spinning is referred to a process of producing fibers from a polymer. The second important terminology related to our topic is viscous fluid. A viscosity is a property of a fluid which offers the resistance to the movement of a fluid. All the real fluids have a certain amount of viscosity, while a viscous fluid has a large amount of viscosity. Example includes higher viscosity of basically the higher viscosity substances are honey, molasses, glue and ketchup. These are the examples of high viscous fluid. In our example, water is less viscous, whereas polymer is highly viscous liquid. Let's talk about the next terminology, melt. The solid material become liquefy by application of warmth or heat. Figure shows when solid material is subjected to a heat, it liquefies. Another terminology is extrusion. Extrusion is nothing but the forcing a melt or you can say molten polymer through a small hole of dye, creating a filament. Yes, this is nothing but extrusion. You can able to see there are three figures. A polymer, which is a thick liquid, when passes through a small hole similar like a middle figure, then fibers are extruded, which is similar like a third figure. This figure shows the thick viscous liquid which when forced through a small hole, then it will take a shape of that hole, the shape of cross section of that hole, and filaments are extruded. This process is nothing but extrusion process. Last terminology that we are going to use in further lecture is nothing but quenching. Quenching is the terminology when used to notify quick cooling of a hot material. If material or let's say filaments is a hot and these hot filaments need to cool quickly, then we call this process as a quenching process. Once we understand the different terminologies generally being used in further lecture, let's get into the main subtopics. Different types of fiber spinning. Earlier I told you the fiber spinning terminology. The fiber spinning is nothing but creation of a filaments from a molten polymer. And in industry, molten polymer is converted into a filaments by three methods. In this figure you can able to see there are three methods available: melt spinning, dry spinning and wet spinning. Let's talk about the melt spinning. In melt spinning, polymer is initially melted and then extruded through a small hole present on a die. Extruded filaments then gets solidified with the help of cool air. Now the fibers, those use this melt spinning technology, examples are nylon, polyolefins, polyester, etc. The second important spinning method is dry spinning. In dry spinning, polymer is solubilized into a relevant solvent and then converted into a polymeric solution. When the polymeric solution is extruded, filaments are created. These filaments get solidified by evaporating the solvents. The PVC, cellulose acetate, these are the examples of a fiber. Those are produced through dry spinning technology. Next, an important spinning method is wet spinning. In wet spinning, fiber forming substance is nothing but our polymer is solubilized into a relevant solvent, similar like a dry spinning. Here, a thick polymer solution is created, and this polymeric solution, when extruded, filaments are created. These filaments get solidified through a coagulation process. Generally, polyacrylonitrile is fiber created with the help of wet spinning technology. Majority of the synthetic fibers produced in this world using either of these technology. Certain polymer is melted after application of heat, but few of the polymer are not melted after application of the heat, but rather they get degraded. Only those polymers suitable for melt spinning, those can be melted without degradation. The process of melting is shown in this figure. It involves the feeding of polymer granules through a feeder into a melt block. Now this melt box comprises of a screw mechanism which is placed at the center and around which electrical heating arrangement. This heating arrangement heats up this melt block at a certain temperature. So melting of a polymer granule takes place into this melt block. The solid polymer absorbs those heat and gets melt into a thick viscous liquid. The process of feeding and melting is continuous process and which is operated by a screw mechanism. The rotation of the screw moves the solid polymeric granules forward and while moving the forward, these granules get melted into a thick viscous liquid. This homogeneous molten thick liquid filtered through a filter. This filtration process is necessary to remove any impurities present in the thick viscous liquid. Otherwise, these impurities further block the holes of the spin rate. Filtered molten liquid needs to feed to a spinnerate at a constant rate. Hence, metering pump are actually in the picture. The rate of flow of melt is decided by the speed of metering pump. Higher the metering speed, higher will be the flow rate of a melt into the spinnerate. Melt then passes through a small holes at the bottom of a spinnerate, and melt gets the shape of a filament. This process is known as extrusion process. Extruded filaments are quickly solidified by applying a cool air. Once cooled, these filaments is applied with a spin finish. These filaments then draw at a desired thickness through a series of progressively speeded drawing rollers. You can see in this figure the second roller has more speed than the first one. Similarly, third roller has more speed than the second one. Progressively, the speed of each roller is increases. This increment in the speed of each roller draws the filament. These filaments get stretched multiple times to their original length, or you can say to a desired thickness. Drawn filaments are wound onto a spool or cheeses based on the requirement. So this melt spinning process involves the 5 stages. The first stage is nothing but melting, that is polymer granules get melted into a molten liquid. Now this liquid is extruded. This is the second major step, that is extrusion. Extrusion is nothing but passing these molten liquid through a small hole such way that filaments are created. Third important stage is created filaments need to cool off, or it gets to be a solidified. So third step, major step, is solidification. Fourth important stage is stretching or drawing. Now drawing rollers draws the filaments to multiple times, it stretches it so that its thickness reduces to a desired level. Now once filament is reduced to a desired thickness, the last task remaining is nothing but winding. So the winding is the last step, or you can say the last important part of this melt spinning. So in summary, I can say that the whole spinning operation is divided into 5 steps. One is melting, second one is extrusion, third one is solidification, fourth is stretching or drawing, and last is nothing but winding. Spinning is another technology where polymer is spun into the fiber. Dry spinning is suitable for those polymer which are not thermally stable, or polymer is not meltable. That means dry spinning is used to spin the fiber whose polymer is not meltable. Dry spinning consisting of primarily the mixture of solvent and polymer to get a polymer solution. This polymer solution is generally called as dope. This polymeric solution passes through a filter to remove any impurities. A filtered polymer solution is then pumped into a spinneret through a metering pump. And as we all know that this metering pump ensures the constant rate of solution flow through a whole of a spinneret. This process of passing a thick viscous liquid, that is a polymeric solution, through a holes of a spinneret is called as extrusion. The filaments are extruded and exposed to hot air. Actually, hot air evaporates the solvent from the polymeric solution, leaving only solid polymer. This process is known as solidification. This hot polymer is stretched to a desired thickness through a series of drawing rollers. The as created filaments then systematically winds on a spool or cheeses with the help of a winding mechanism. The name dry spinning given to this technique is because fiber solidification takes place in the dry condition. Now in general, we can say the whole dry spinning process is divided into a certain stages. Number first stage is called as dope preparation. Here, as we all know, the polymer cannot be melted with the help of heat, and that's why it need to be converted into a solution. So how it could be created? The polymer first dissolved, or you can say solubilized into a solvent, like sugar is dissolved into water. Similarly, polymer is dissolved into a certain solvent and a viscous liquid is created. That process is called as dope preparation. Once that polymeric solution or thick viscous liquid is created, dope is created. Now this polymeric solution is then filtered and extruded. Extrusion is another main or important stage in the dry spinning after dough preparation. Now here actual filaments are created, but these filaments contain a solvent into it, and that's why solidification is necessary, that removal of solvent is necessary, and this removal of solvent is takes place by applying hot air. The hot air evaporates the solvent present in the fiber and fiber quickly solidified. So solidification is a third important step. Already we know the fourth important step is nothing but drawing, and drawing does its work of stretching. Stretch the filament to a desired thickness. So once stretched to a desired thickness, these filaments is wind on a particular package. We call it as spooling or cheesing. So spools and cheeses is over which this drawn filament is wind. So in total we can say there are 5 different stages in between into which this dry spinning is divided. Number 1, dough preparation. 2, extrusion. 3rd, solidification. 4th, stretching or drawing, and last one is nothing but winding. Wet spinning is another technology to produce fibers from a polymer. This technology is similar like dry spinning, but with a little difference in the solidification process. Wet spinning can be used to those fibers whose polymer does not have any kind of melting point. That means the polymer which is not meltable. Such a polymer, when need to be converted into fibers, we generally prefer dry spinning or wet spinning. The wet spinning consisting of first step is nothing but preparation of dope, that is mixture of polymer and solvent. This polymeric solution is transferred to a filter to remove impurities. Filtered polymeric solution then passes through a spinneret which is immersed into a coagulating bath. This coagulating bath is a mixture of certain chemicals. Metering pump decides the constant rate of a flow of a polymer passes into the holes of a spinneret. The process of passing a polymeric solution through a small hole is known as extrusion. The extruded polymer solution is called as extrudates. Solidification takes place when extrudates come in contact with chemicals present into the coagulating bath. Here, this solidification is the result of interchanging the solvent with the chemical present in the coagulating bath. Chemical present in the bath diffuses into extrudates. Similarly, solvent in the extrudate diffuses out into the bath. Precipitation of a polymer takes place. This is called as solidification process. Fiber, when solidified, it is washed thoroughly, completely. Washed multiple times till a traces of solvents get removed out. Filament stretches further to a desired thickness by using drawing rollers. This stretched filament systematically winds on a spool or cheeses. So in general we can say the whole wet spinning process is divided into 5 different stages. Number 1 is dope preparation. Second one is a very crucial part of this spinning is extrusion processes. Now after extrusion, the third important stage is nothing but solidification, then stretching and drawing, and ultimately winding. So in total there are 5 steps present in the wet spinning.